There's something in the universe pulling our entire galaxy, and we still don't fully understand what it is. Astronomers call it the Great Attractor, a mysterious region of space so massive, so powerful, and so hidden behind cosmic dust that even today we can barely see it. Yet despite being almost invisible, it's dragging the Milky Way and hundreds of nearby galaxies toward itself at more than 2 million kilometers per hour. Let's explore what the Great Attractor might be, why it pulls so strongly, and what lies in the darkness that our telescopes still can't reveal. A strange motion in space. In the 1970s, astronomers discovered something unusual. Galaxy clusters, including our own, weren't just drifting randomly as the universe expanded. Instead, they were all moving in the same direction. This motion was too fast and too coordinated to be explained by ordinary gravity. The galaxies were flowing toward a single region of space in the constellation Centaurus. It was as if something enormous was hidden there, pulling them in. But when scientists pointed their telescopes toward that region, they saw almost nothing. Why? Because the Great Attractor lies behind what we call the zone of avoidance, a dense dust-filled band of the Milky Way that blocks our view of what's behind it. Trying to observe that region is like trying to look through a brick wall, so astronomers had to rely on the only thing that remained visible: the motion of galaxies themselves. And they all pointed to the same conclusion. Something incredibly massive was hiding behind the dust. The clues we've found. So far as telescopes improved, astronomers finally began to piece together what might be there. It turns out that the Great Attractor is part of a gigantic structure called the Laniakea Supercluster, a web of more than 100,000 galaxies, all connected by gravity, all flowing toward the same gravitational center. But even Laniakea doesn't explain everything, because the Great Attractor isn't just a cluster of galaxies. Its gravitational pull is far stronger than the matter we can see. It's almost as if something even larger and even more massive lies deeper behind the dust, something we still can't detect directly. And that leads to the biggest mystery of all. Is the Great Attractor just the beginning of an even bigger structure? The Shapley Supercluster. Beyond the Great Attractor lies another region, the Shapley Supercluster. It contains more than 8,000 galaxies and may be one of the most massive structures in the local universe. Some scientists now believe that the Great Attractor might not be a single object at all, but part of a chain of superclusters stretching far across space. If this is true, the gravitational tug we feel could be coming from a whole network of enormous cosmic structures pulling on each other. But even this explanation doesn't solve the entire puzzle, because the motion of galaxies still seems too powerful to be explained by Shapley alone. The dark matter problem. To explain the Great Attractor's strength, astronomers looked at dark matter, the invisible mass holding galaxies together. If a huge concentration of dark matter exists behind the dust of the Milky Way, it could explain the gravitational pull without needing visible galaxies. This idea is compelling, but there's a problem. We can't directly detect dark matter. We can only measure its gravitational effects. And so far, the dark matter in that region still doesn't fully explain why galaxies move so quickly. Something still seems missing. The wildest theory. Some scientists propose a more radical possibility, one that stretches beyond the observable universe. Maybe the Great Attractor isn't a single object, or even a cluster of objects. Maybe it's the gravitational influence of structures outside the part of the universe we can see. In other words, something beyond our cosmic horizon may be pulling on us. This idea is known as the dark flow hypothesis, the suggestion that the motion of galaxies is being influenced by something huge that lies outside the observable universe entirely. If true, it would mean that our universe is just one part of an even larger cosmic landscape. A place filled with giant structures we can never observe directly, but whose gravity still reaches across space. Should we be worried? Here's the good news. The Great Attractor isn't a threat. We're not falling into it like water down a drain. The universe is expanding faster than gravity can pull us in. Instead, the Great Attractor is simply shaping the motion of our galaxy through space. We're riding along a cosmic river of gravity, one that has been flowing for billions of years. And even though we're moving at incredible speeds, we would never notice it. Space is too vast, and gravitational forces are evenly distributed across huge distances. But scientifically, the Great Attractor is one of the most important clues to understanding the large-scale structure of the universe. It tells us that our galaxy is not isolated. It's part of a much larger cosmic web, influenced by forces far beyond our view. The mystery remains. Despite decades of research, the Great Attractor remains partly hidden, partly understood, and completely fascinating. It raises questions about the true size of the universe, the distribution of dark matter, and the possibility of structures beyond what we can ever see. One thing is certain: something massive is out there, something powerful enough to move entire galaxies. And as our telescopes improve, we're slowly uncovering the shape of the cosmic landscape we're traveling through. The universe is not just expanding, it's pulling, pushing, flowing, and guiding everything within it. And somewhere ahead of us, hidden behind the Milky Way's dust, the Great Attractor continues its silent pull, a reminder that the universe still holds enormous mysteries waiting to be discovered.